In this video, we're going to be talking about Euler circuits. So let's go and get started. Now, the best way to talk about an Euler circuit is to actually look at an example. So in this example here, we have a small town, and if you read the directions, it says a major snowstorm has swept through a very small town in North Dakota. You must use the snowplow truck and clear the streets. So it tells us that, okay, here's our little town here. All right, so here's our little town. So we have all these little roads going everywhere. All right, so that's just making sure we can read the graph correctly. Now it says, starting at the maintenance shed, you need to find a route that allows you to clear all the streets exactly once in return. So basically what that means is we're going to drive across the streets exactly one time. So like for example, and again, I know I'm probably going more in depth than I need to, but if we started at the shed, because that's where the maintenance shed is, if we were to go all the way to Kroger, see that street? We cannot go back. We cannot go back. All right, so that would be against the situation. All right, so let's see if we can do it real quick. All right, starting with the shed, let's say we just go to Kroger. We wanted to go to Kroger for some odd reason. All right, now we're going back to City Hall, and then we're going to the gas station, but oh, we got to do this guy right here, go right here. Uh-oh, we're stuck. Okay, well, that's not good. Can't do that. All right, so let's try it again. All right, so maybe that wasn't the route. So let's say we went from the shed, then we went to City Hall, we went to Kroger, we came back to Kroger, or we went back to City Hall on that street. Now we're going on this street to the gas station, and let's say we wanted to go to the shed, and then we went to Kroger. Oh man, we still cannot find that one last one, so we can't find a route. Now, if not, is there another place that you can start that allows you to clear the streets? So in this example, okay, so maybe we don't have to start at the shed. Let's say if we decided to start at, I don't know, City Hall. Maybe that's where the truck was parked. So all right, then we just start, okay, gas station, this guy, this over here, there. Nope, dang it. We just can't do it. So basically what we have here is a situation where, no, you cannot do everything one time or do all the streets exactly one time. All right. And what we're doing is what is called an Euler circuit. All right. So an Euler circuit is nothing more than a route I think it's supposed to say a route that goes through a graph or route in a graph, whatever, and begins and ends at the same vertex and goes through exactly one time. So like this for this graph right here, watch what I do. All right, so I just started at E because I wanted to, but let's say if I went to B and I went to A, I went back to E, but now I went to D, I went to C, went back to E. Notice what I did here. I started at E, I was able to trace every edge exactly once and got back to E. So this is what is called an Euler circuit, okay? Now, basically an Euler circuit is nothing more than can you retrace the graph? That's really what you're doing. Okay, so it's an actual pretty easy concept. Now, one thing that you can do that's really going to help you out, and that is all the vertices must have an even degree. Okay, now what I mean by that is going back to this example here. Like if I was to ask very simply, what is the degree of A? Well, there's two edges touching it, so the degree is 2. The degree of B, same thing, 2. Look at E. How many vertices are touching, or how many edges are touching it? Well, that'd be 4. C would be 2. D would be 2. So notice that all of these, I don't like the way I wrote that too, all of these degrees or all of these vertices have an even degree. So that means that there is an Euler circuit in this particular graph. Now let's go back to this guy right here. All right. Now let's just count up the degrees. All right. So the shed has 1, 2, 3 roads connected to it, so that means the degree of 3. Right then and there, because of the fact that this one vertex has an odd number degree, I already know that no, I cannot make an Euler circuit out of that. So we're almost like designed to fail to get started. Now, if you just want to keep going, Kroger has 3, City 1, 2, 3. I think City Hall has 5, gas station is 3. Yeah, they're all odd, but they have to be all even. All right. So an Euler circuit, again, all the degrees must be even. And lastly, there can be several routes. So let's say if Johnny in first period wanted to start with B and then he went in this direction. Well, he would be right. But let's say little Sally in fifth period say, you know what, I want to start with C. And then if I go to C, I go to D, and then maybe even just do a couple of weird stuff here. Boom, boom. That's perfectly fine too. So there's many, many different things. All right, let's do a couple examples. First off, do these graphs have an Euler circuit? Label the route you made. Now, here's what I do, and this saves me a lot of time. And that is based on what we just went over, I look at one thing and one thing only, and that is all the vertices must have an even degree. That's what I look at. That is the very first thing I do. I analyze the graph based off of the degrees. So here we go. Starting with A. A has a degree of 3. I already know, boom, right then, it's not going to work. Okay? It has a degree of 3, and it has to have all even. All right, let's look at this one over here to the right. I always like to start with the first letter of the alphabet, which is A. What is the degree of A? Oh, look at that, 3. Oh, can't do it. So right in there. I just saved myself a whole bunch of time because I did that in like 10 seconds. Now let's look at this one. Again, I always like to start with A and work my way around the horn. 1, 2, 3. So A has 4. B has, oh, look at that. B has 3. So, boom. Nope. It's not going to work. Because, again, remember, all the vertices must have an even degree. And it, as you're working through it, so let's say if rather than doing B first, you went to G. Well, G has 2. Okay, good. F has 4. E has 2. C has 1, 2, 3, 4. D, boom, 3. Oh, there it is. So you can work through all the degrees, but the second you hit an odd degree, you're done. All right. So let's look at this one right here. All right. Give you all a second. A has 4. Oh, that's good. B, boom, look at that. 3. Nope. No dice. That's going to be a no as well. All right. Let's look at this one over here. So we'll just start with F. F has a degree of 2. G has a degree of 2. H has a degree of 4. Oh, so far so good. J has a degree of 2. K has a degree of 2. All right. So, yes, this will have an Euler circuit. Now, the next thing is, let's find our route. Now, the way you do your route, it's totally up to you where you start from. Unless it tells you where to start from, it's totally up to you. So, eeny, meeny, miny, I'm going to start with F. So, starting with F, going up to G because I wanted to, going to H because I want to, J because I want to, K, J, back to F. That's perfectly fine. And then let's say you're someone, I want to start at J. Okay, start at J. I want to go to H, then F. I want to go to G. I want to go to H, back to J. Boom, there you go. Perfect example. All right, let's look at this guy. All right. Will this have an Euler circuit? Let's see. We'll start with A. A, 1, 2. Look at that. A has a degree of 3. Nope, that will not have an Euler circuit. Pretty simple. All right, let's draw a graph and figure it out. All right, so if you remember from the previous lessons, all of these represent edges. All right, if you notice, the first one out of the gate is A to A situation, so that's going to be a loop. And then next is going to be A to B, B back to A right there, B to C like so, B to D, E to D, E to C, E to A back to E, and then B back to D. Well, there's our graph. Now let's see if we have any, let's see if we have an Euler circuit. So let's see. A has 1, 2, 3, 4. Okay. A has a total of 6 degrees. B has a total, look at that. B has 5 degrees. No Euler circuit in that guy. Now, the last thing we're going to go over, and that is what is called a directed Euler circuit. Same concept, the only difference is now you're dealing with a digraph. Now, what's very simple about this is you just simply go by the directed edges. Just go by the arrows. All right? So here is my digraph. Notice that the arrows. Now, what I mean by you have to go by the arrows, and that means if you were sitting on D right here, you cannot go back to C. That's going against the arrow. These arrows, these directed edges are a one-way street, okay? So if you're sitting on D, you have to go to A, all right? You have to follow the arrow, all right? Now, you still have the same concept of degrees, except now it's in degree and out degrees. All right, so what that means is how many arrows are pointing to a letter, the same have to be leaving the letter. Okay, so like for example, look at A. Notice how you have, very simply, two arrows coming in. Okay, and I know it's directed edges. I'm just saying arrows because it's faster. So you have two arrows in. How many is leaving? Two arrows out. Okay, that's good. Look at C, same exact thing. Two arrows are coming in. Two arrows, too many R's there, are going out. Okay, let's look at D. D, one arrow in, one arrow out. Look at B. All right, how many arrows are pointing at it? Two arrows. Two arrows in, two arrows out. Notice how each vertex has the same amount of arrows coming in as the arrows going out. That means it has an Euler circuit. So again, starting at any place you want to start at, again, whenever I tell students you can start anywhere, that usually freaks them out. All right, so I'm going to start with A just because I want to. So I'm starting with A, drawing an arrow to, or drawing a line up to B. I took that arrow. That's fine. Now I went that way. Okay, let's say if I decided to go back in that direction, back in this direction. Okay, now I'm back at A. Now I only have one choice, and that is to go to C, that direction, go to D in that direction, and then go back to A. Boom, there you go. So there is my directed Euler circuit. All right. Again, what I would do is I would analyze everything first before figuring out if it had, or rather than guess and check. So if you notice, A has two arrows going out, two arrows coming in. B has one arrow going out, one arrow coming in. C, one arrow in, one arrow out. D, two arrows in, two out. Okay, so it looks like the arrows check out. So here we go. Starting, I just always like to start with A. I don't know, no reason for it. All right. Now I'm going to go in that direction. All right, now we're back to B, and then we're back to A. Boom, there we go. That's it. That's how easy it is. All right. Construct, and this will be the last one we're going to do. It says construct the following digraph. Does it have a directed Euler circuit? All right, so a directed digraph, all that means is basically the first letter is going to the second letter. So see where it says AB? That just means that, or AB, boom, there it is. All right, A to E, B back to A, E to D, B to D, B to C, and then D to C. All right? Now, analyze. Well, let's look. Look at vertex A for a second. You have two arrows leaving, one arrow coming in. Well, that right there, that tells me right there, the in degree and out degree is not equal, so that right there, boom, no dice. All right, even look at C. Just look at C, for example. See how you have two arrows going in, which means you should have two arrows going out, unfortunately. Look at that. Two arrows coming in, that's all you got. So I would say, again, just looking at A or C, heck, you can look at B. Look at B, three arrows going out, one arrow coming in. That's a mismatch. Look at D, two arrows coming in, only one going out. So because of all that craziness, this would not have an Euler circuit. All right. Well, thanks for watching. Hopefully that was easy to understand. Let me know if you have any questions. Thank you.